Ready?
Ya. Sí,
Right.
listo.
Ready? Yeah, I'm going to introduce you. Okay.
¿Perdón?
Okay. Good morning, everyone. Jose Garcia, I'm supposed to be able to present Eugenio,
Eugenio.
what is more important than mine. So let me to summarize. Everything is in the web. You can see his CV, but Eugenio is the man behind the data, or the man behind the acronyms. So he started was born in Maracaibo, the north of Venezuela, very close to Caracas, a city of 3 million people, so it's a big city. From there, he studied in Caracas in a university called Catholic University of Andrés Bello, and I discovered Andrés Bello was from Venezuela, was founded of the Chilean University.
Yeah.
From there, he moved to Boston College to study because his undergraduate was on psychology, right? Psychology. Right? From the Boston College. So this is the first time he arrived to Boston College in 1994. Before someone of you were born,
86.
he was doctor. Okay, 1994, he was already doctor, right? So it's in educational research, measurement, and evaluation from Boston College. And then he started to move from different places. So some words like ETS, you might know about that, ETS, and EAI in Hamburg, and also the International Center for Studies on Pearls teams in Boston College, funded by him, and other. I mean, he specialized on quality control, using all the data and all the collecting information. Remember this process of the name is analyzer, EDB analyzer. He's also the man behind that data. Okay, so everything is about using data, collecting data. So he started with the teams and pearls, and from there moved to ETS and started to work with PISA and PIAC. So he knows everything about everything, right? And also he's a runner, okay? I mean, this is something definite. I mean, to summarize, he's a runner, okay? And he's Eugenio. Thank you, Eugenio.
Gracias. Thank you. Thank you, Jose, for an introduction. Yes, I'm from I always like to say that I'm from Venezuela, but I left when the previous thieves were running the country. So if you know what I mean, then, so I left Venezuela in '86 and went to the US and stayed since then, and have been working on, sometimes it's you want to be ready, but you also want to be lucky when you're ready. And I was ready and lucky because in 1993, TIMS was being run out of Canada, and it was transferred to Boston College to be run by the professor that I was working with at the time. So that's how I ended up getting introduced. I was a year from graduating, and I was trying to figure out where to go, what to do. And in August of '93, we started working on this. I stayed at Boston College till 2004. I went to ETS in New Jersey, in the United States also, and then I came back to Boston College 2 years ago. The person that replaced me 20 years ago was retiring, so they called me to see if I wanted to come back. So I think, and again, I think it's a matter of being ready and lucky at the same time. And I think this, as I'm saying this, I think this is a bit of an underlying theme in the work that we do, that we're trying to be ready, collecting data, having the right instruments and so on, but we also want to be lucky in the sense that sometimes the work that we do doesn't get accepted, or it doesn't get implemented, or the right conditions are not happening in the country or in the region. So I think, but that doesn't mean that we should not stop being always ready, but we always want to be ready, and the work that that you do, that we do as collecting data, analyzing and reporting is part of being prepared so that when the right moment comes that we can take action based on the information that we have. So, and I also my research, I don't have much published research in terms of the results of the studies. My work is around how these assessments are designed, how they're implemented, and things that we do to make sure that the data, when it comes out, it's usable, that is of good quality, that is believable, and also we spend a lot of time training people on using the data, so to apply the proper statistical methods. So over the 30 plus years that I've been working on this, there have been many, many changes that have happened. So I'm going to try to touch on some of those changes and how they have affected what we now have and what we now do. I want to talk about the advances that have happened in the areas of test development, operations, psychometrics, and reporting, and the curricular expectations, how those have changed over time. Not in full detail, but also always in the US we say with a bird's eye view, so as like a flyover. So I'm not going to get too deep into some things, but I want to give at the end give you a picture of what happens behind the scenes, the things that we're working on that will come out in the future, and that's what I'll do. The presentation will conclude with a review of some of the newer technologies and processes that are being under development and implementations, and how these might shape the future of large-scale assessments. One of them being the collection of process data, and in the previous session, Mark, who is here presented an example of how the process data can be used to look at response time and performance on a longitudinal study that we did in between 2023 and 2024. So the title is From Fax Machines to AI, because when I started in the 90s working on this, the email didn't exist. I don't know if you can remember a time when email didn't. There was no email, so we would send, if we needed to communicate with somebody, we would send them a fax. Somebody would type something.
No mobiles.
What's that?
No mobiles neither.
No mobiles, no nothing. So you had to type something. We had computers. You had to print it, and then you had to put it through this machine on the left, and it would show up in the other end. And there were, many versions of that. There were machines that share a telephone line, so that somebody would pick up, and then they would recognize the signal that there was a fax coming, and they would have to press a button for the fax. So if you had a country that was on a different time zone, you couldn't send them a fax when there was nobody in the office. So you had to be up at the time that somebody was in the office to send them, to be able to send them a fax, or somebody there to pick up the phone and make the transfer. We also spend a lot of time shipping paper. We would print the reports. We would print like you would come to a presentation like this, and everybody would get a piece of paper with the slides of the presentation, and so on. And that's pretty much gone now. Like it is, we're not paperless completely, but there's a lot of the paper that was used before is not done, and it has been replaced with newer technologies that we use to make our work faster, more efficient, and more effective in the end, and then more useful. But then also it allows us to do many, many more things. So we don't see. I don't know that there's any fax machines that exist anymore. In fact, the current telephone lines do not support the transmission of the signal of a fax machine, because that was an analog transmission, not a digital transmission. So there was a time when you had to keep an analog line to be able to keep sending or receiving fax, and everything else moved to digital lines, which is what pretty much gets used everywhere. Now, of course, there was a machine that converted the analog signal to a digital signal to be able to still send the copy of the paper. But as you see over the years, there's many changes, many transitions, and we have to adapt. And in this context, when we're designing these assessments, we also have to think of what can we do today, but then also what is it that we're going to need tomorrow. We start designing an assessment today in 2026, or in 2027, we'll start designing the PEARLS assessment that's going to be administered in 2031. So we have to have a bit of a vision or a crystal ball to figure out what is it that we'll be able to do in 5 years that we need to get ready to do now. So what did I mean by AI? So the fax machine is obviously like a machine AI, and I want to tell you how I QC my presentation. I did it, and then I went to ChatGPT, pasted it, and said, "Tell me what's missing," and it was really good at telling me what was missing. And I didn't use everything that ChatGPT was telling me, but it was a very nice way of QCing the presentation. Before I would have sent it to 2 or 3 people. There will be multiple checks. But even within preparing my presentation, Microsoft PowerPoint will tell me if a word was misspelled. It would tell me if the syntax wasn't right of a sentence. So there's AI in the background that is being used all the time, whether we know it or not, in all the processes that we carry out and that we use in our daily lives. So AI is not a new thing. It's a thing that has been under development for many, many years. Pepe said I studied psychology, and when I studied psychology, I remember one of the things that we studied is that at the time, IBM was developing a system called ELISA, which would allow you, the idea was that you could talk to the machine, type to the machine at the time, and the machine would respond to you empathically, with empathy. So that was in the 60s that IBM was working on something like that. They were working on chess games, how to play chess with the machine, and there were competitions between the human and the machine. So it's nothing new. The thing is that the greatest development that we have now is these large language models that you can kind of like talk to the machine, or you can give it. And talk is humanizing the machine. You can type text, and the machine will type text back to you that makes sense based on the text that you typed to the machine. But the machine is not feeling. The machine is not emotionally engaged in what you're doing, but it is responding in the using the rules of being engaged in a conversation. So that is a huge shift that is important for what we do, but also for what we have to assess when we assess the students. So we have to be able to assess that, or assess skills or capabilities or knowledge that the students need to know to be able to operate in that environment. So artificial intelligence is, I looked at the definition. It says, is the ability of machines or computer systems to perform tasks that typically require human intelligence. Now we know they don't. Just requires an intelligent human to figure out the algorithm that is going to act as a human, and such as thinking, learning, problem solving, and decision making. It's about creating intelligent systems that can understand, adapt, and act in complex situations, making them useful for a wide range of applications that simplify and automate human tasks. So we always talk about this as if they were replicating human tasks, but sometimes they do things that humans cannot do, or they cannot do as quickly. And that's what we have. Autopilot. We have security systems that can detect things that a human eye cannot detect. So it goes beyond. It goes beyond what humans can do. So it's not only mimicking human, but it's going way beyond what a reasonable, normal human is able to do. So, but let me recap a little bit what are large-scale assessments to contextualize where this falls and where the direction that this is going. Large-scale assessments are, people call them tests or exams, so they're really surveys of knowledge. So we want to know, the questions that we want to know is, what is it that students know and can do of a framework that we have defined. So it's a group of experts that says, these are the things that we expect a fourth grader, for example, or an eighth grader in the case of TIMSS or Pearls. In the case of PISA, what are the skills that a 15-year-old is expected to have to perform and be a productive citizen in the 21st century? So that's a framework, and then the role of the exam, or the test of the is to survey to see whether overall, on average, the students have these skills or this knowledge, they have acquired this knowledge. They're known as group score assessment because their focus is on optimizing reporting at the group level and not the individual. So they should not be, that's why you've seen in the literature that they shouldn't be used for individual reporting. Although we do have individual records and individual performance to then be able to infer to the group. They're considered large, not because of the amount of people assessed or the length of the instruments, but because of their goal to assess several domains and contextual variables and report the results over a broad spectrum of demographics, but not for individuals. And here there's always a level of degree, so if you have nothing but a large-scale assessment to assess somebody, should you not use it? It's not optimal, but it does give you some information for an individual. In the same way that a test that's designed for individuals, like an admissions test, a selection test, could also be used to make group inferences. But the statistical techniques that need to be implemented are somewhat different, to account for the uncertainty of what you're doing and to account for your ability to be able to then make inferences and make decisions based on that information. In the case of large-scale assessments, we're more interested in making group-level decisions. So we have the luxury of allowing ourselves to measure students less reliably, but we want to measure the whole population more reliably. So that's why we need more people. That's why you see the sample sizes being in the thousands, and we want to have 700-800 student responses per questions to then be able to infer from those to the population. Over the past 20 to 30 years, large-scale assessments have become ubiquitous in the field of education. Names like PISA, TIMSS, PIAC are relatively well known, and I see that many of your papers use those data sets. There's ICILS, also an information and computer, international computer and information literacy study. There's an ICCS, it's a civics and citizenship education study that have become regular. And they become regular because now we have the techniques and the machinery, going back to the fax machine and the copy machines, to be able to do this every 3 years, every 4 years. Before, the cycle between these studies was tens of dozen years, 12 years, 20 years in between, because to be able to get the data files as an anecdote, when we started working on this, and I wanted the people from Germany were preparing the databases, and I had to tell them on Monday that I wanted a database, and they would create the disks at the time, and then on Wednesday it would be ready, and they would ship it via Federal Express, and I would get it on Friday. If I was lucky, if it was any delay, then I would get it on Monday. So now I tell them I need the database, and they can send it right away, or it's in the cloud, and as soon as I put it there, I can access the database. So the processes that we have now are much quicker, much more efficient and effective, and then we can do more, which is one of the greatest advantages of the expansion of artificial intelligence systems. So large-scale assessments are designed to have little or no consequences to the individual because of the low-stakes nature. Their designs are optimized for reporting at the group level and do not emphasize accurate measurement of individuals. And this sounds a little bit contradictory, that to infer to the group, we don't need reliable, or like we can compromise a little bit in the reliability of the students, and it's because we have there's a layer of statistical methods on top of that allows us to infer to many people things that we don't know about them, but we know about others that are like them. And I'll give you an example, and I'll make Pepe stand up to show you how that gets on. Not yet, in a little bit. So the commonly assessed domains, the ones that you know about this, mathematics, reading, scientific knowledge, and skills, civics and citizenship, computer information, computational thinking, problem solving, financial literacy. And there are also new domains that are coming up. Learning in the digital world is one that the OECD reported on, I think they will report this year. And then there's media and artificial intelligence literacy that will be part of the PISA assessment in 2029. What they're not intended to be used for reporting performance of individuals. They lack this level of precision. They're not intended to be used for accountability purposes of individuals or small groups. So, difficult question. We had before this talk, the radio was here, and they were asking me questions about. They want to know the radio, the news, the news media. They want to know with certainty, like what about Rioja? Like how's Rioja doing in the assessment, and what's your recommendation about Rioja? And I think part of the answer is, well, I don't know. We know some things, but there's a level of reporting to which this is optimized, and there's a level of reporting below which the results are just not optimal and not good to be used for decision making. They're good to be used as an indicator, but not to start making decisions. They're not limited to assessing in-school populations. So we have, there are in-school surveys like PISA, TIMSS, PEARLS, and so on, where we test the students in the schools. And there are tests like PIAC, where we actually go to the homes and interview people. And one of the challenges here is, participation. So one of the greatest advantages. That's one of the things that the person on the interviewer was asking me about given the expansion of technologies. The expansion of technologies is great, but now people know about this. People know also there's a new set of risks in terms of disclosing information, privacy protection, and so on. That even though we can do a lot more, then people are more aware of what we're doing, and people are more aware of what could be done. So when you show up at somebody's home to do an interview, or people are like, what is this about? Is this a government? Is this a fake? Is this a phishing expedition? When we go to the schools, the parents are like, you're testing my child. I didn't authorize that, so we need to get parents' authorization. So there's a bunch of logistical challenges that come up with the developing with the implementation of these new technologies. They're not to be used to dictate curriculum or teaching methods. What applies in one country doesn't necessarily apply in others. And one thing that I also like to clarify when I talk about this is that they are not. When I say they should not be used for this, is that they're not optimal for this. They're not optimized for this. So, could you take one of these tests and make inferences or make some curriculum changes? Yes, you can. But you want to be able to have the right information and have enough of the right information to be able to use this data for decision making that has consequences to the people. So, and this goes to the mission of the organization, that part of the role here is to have a body of evidence that supports decision making for policymakers, so that when the right time comes, those decisions or those recommendations could be implemented. I want to also touch on what is a test. Again, to contextualize what large-scale assessments are about. In general, a test is a collection of evidence that shows what test takers know and can do in a domain of interest. So we're collecting evidence, and we have so much time to collect evidence. We have typically about 2 hours, and if you're assessing one subject, you're lucky because you have a lot of time, but if you want to test math, science, and reading, then you have to be able to figure out how to slice the time to cover the 3 subjects. If you have like PISA ends up combining math, science, reading, financial literacy, and a innovative domain. So they have 5 different areas in which they want to report, and then you have to be able to optimize your design to be able to cover all those topics and report on them with some degree of reliability. So we're collecting evidence, and we want to collect as much evidence from as many people as we can, and that's why the samples are large and the pool of items is very large. So in TIMSS, we have about 300 math items and science items per grade. So 1,200 items that we're using in the data collection. And we also want to be able to administer these, minimizing interference of irrelevant variance. And I'll give you an example. We were talking about this yesterday in PIAC. There is a question that had presented the adults with 3 schedules. And the answer was, pick the schedule that will allow you to arrive by 7 p.m. Now, in English, arriving by 7 p.m. has a very clear meaning, which is you want to arrive as close to 7, but before 7. So in Spanish, and so what happened is that item was not working well in Spain. And I read the item and it said, we don't arrive by 7 p.m. You arrive before 7, after 7, or around 7, which could be, you could be 5-10 minutes late. So
sobre las 7.
Sobre las 7, yes, around 7. So the item, this question was trying to see if the person could work a schedule. And you could still work a schedule. I could work a schedule and then still pick the wrong one because in my cultural context, arriving by 7 meant something different. So that's something that has to be accounted for and has to be incorporated in the design, the development of these tests. And it's something that, when they talk about using AI system for translations, this is something that an AI system needs to be able to account for. I don't know that it does. I'm not saying that it doesn't, but part of the talk in the development of these large language models is to be able to adapt context and different cultural context to the specific translation of the text that is being translated. And this plays out, and I'll touch on this later when we're dealing with one of the things that we're working at Boston College is we have questions where the student has to write a response. Give a reason why when you have the air conditioning on, you should have the windows closed, right? So then the student types. And I'm asking that because I came here, the windows were open, the air conditioning was on, and I closed them. But the AI needs to be able to understand the context under which that happens, and to be able to understand what the student means by their response, and being able to score that according to a scoring guide, a specific rubric for scoring those questions. So part of the challenge here in developing the assessments and implementing these large language models, for example, is to be able to take into account cultural differences that it's not just between 2 cultures, but it's between multiple cultures. In the early days, one of the things that would happen is if you had multiple choice questions, most of these were developed in English, and in English the words don't have gender. There are no male and female words. In Spanish, the words are male, female, or neutral. So if you had a question and you had 4 options, the options have to be of the same gender. So you couldn't have options that you could have options that have different genders, but then you have to somehow account for the genderness of the option to be able to get the question right. So within this, so the test is gathering evidence, and then the question is how do we put together that evidence? And then there are two perspectives that are underlying how we deal with these results. One is the psychological perspective, and that's the one that we use the most, and this the one but we use the most because it's the most useful. So when we talk about the scores on the test, when we talk about the item response theory, we're talking about this perspective. We're assuming that there is a construct, a thing that we made up and we call mathematical literacy, mathematics knowledge. And we also talk that we can define that as having little of that and having a lot of that. And we have questions that are easy and questions that are hard. And if we know the hard ones, we likely know the easy ones. And if we don't know the easy ones, it's unlikely that we know the difficult ones. So it assumes that there's this theoretical continuum that goes from low to high, and that we can place the questions along that continuum. That's a psychological perspective, and that's the one that it's used most of the time. And then there's the educational perspective that says, no. We have, during the school year, we're going to teach 100 topics. And at the end of the school year, we want to know how many of those topics, how many or what percentage of those topics were mastered by the student. So if I want to know that, now I have to do a selection of those topics to make my test. And then if I have different tests, I have to make sure that that selection of those topics is comparable to the others. I have to assume that unless I want to put them all together and take the psychological perspective. So another example, when we were driving here, we were talking about the evaluations in Spain, and there's apparently there's 17 countries, autonomous communities, and each one of their university system has their own test. And then if you take a test in one, it might be easier or more difficult than the other. And there's no, as far as I understood, there's no way to compare the results on the 17 tests beyond saying how well you did in one relative to the people in that place that took that test. So
we were discussing on university access.
To access university, yes. Admissions test, right? Yes. So your performance on the test is determined by how much you know, or how well you do, but that how well you do is defined on how well everybody else did. So if you are a poor performer and you take the test with people that are poorer performers than you, then you do very well. It's like he would talk about running. If I run in a race where where all the slow ones are, then I can do very well. But if I run in a race where all the fast runners are, where the winners get money, then my performance could be the same, but my position would be very, very different. And we're interested not in my relative position in the running world, but how am I getting better at my running or not? So that's part of the challenge, and that's why these two perspectives are important in the sense of when it comes to summarizing the scores and then being able to choose the techniques that allows us to summarize the performance across the different assessments. So we have the psychological is where are you in this continuum. The educational perspective is how much of this body of knowledge have you acquired. They're similar, related, but not the same. So here I expand a little bit on those ideas that the assessment has to be different. The techniques that are used are also different depending on which which perspective you're taking. We're taking the perspective of the psychological perspective, that there's a continuum. There's low performance, high performance, and there are questions along the line that we can place. So how high can you jump? And here I want to illustrate. So let's say that we have two high bars, to see how high Jose can jump and how high I can jump. And one is in, and I guess I missed the graphic here. One is supposed to be in inches and one in centimeters. So I've converted them both because I want to know a 100 in inches is 220 in centimeters. So if I say I jump 100, you need to know the metric to then convert it to centimeters. So I converted to centimeters. And now we have the case that we have this guy trying to jump, and you say, well, if you want to know how high this person can jump, are you going to make this person jump A or B? And I think you would all choose A. And then you have this person and how high this person can jump. And you would say, well, that person, you can make it jump A or B. And then you have this person. And then you could say, well, probably B, right? But even though you have two different instruments, you can report the results on the same metric. Because you have equated the scales in which you're measuring. Now, Jose and I, you make us jump. And Jose and I jump 60, 70, 80, and then we fail 90 and 100. So we're both here. And I ask you, how high can I jump? And you would say,
up to 70.
You would say, okay, he says up to 70. No, up to 80. I jumped 80. So how high can I jump? You would say that you don't know. Because you maybe jump 60, 70, 80 once, 90 once, 100 once, and I failed 90 and 100. But you don't know if I can jump 90. You gave me only one chance. I can say, hold on a second, let me try again. And that's why in the Olympics, you have 3 tries. To the jump, all the jumps, you have 3 tries. And even when they throw things, you have 3 tries. So even though we perform the same, first of all, you don't know how high either one of us can jump. But even though you have one snapshot of how we jumped, you don't know how high we can jump because you didn't ask us to jump enough times. However, if I say, if we're to jump 90 again multiple times, who's more likely to be able to jump 90? Jose or I? And you would say, you would stand up?
Yeah.
So you would say, who would be more likely to jump 90?
Camera.
Yes. Right? So you would say, well, Jose is taller. I think he's younger than I am.
Yeah.
Right? So, thank you. So you would say, well, I don't know, but I know that Jose is taller, Jose is younger, Jose maybe runs more, Jose may be less heavy or thinner. So you don't know, but you have an idea of how other people would do when they jump 90, when they do 100. So then you can build a confidence interval around that number, and then say, well, chances are that if you were to build a distribution of possible outcomes around those points, that his distribution would be higher than mine. And I got lucky by jumping up to 80, and he got unlucky jumping only up to 80. So that's the concept of measurement uncertainty, but also of the plausible values that you use and the imputations, because based on a limited number of observations that you have, you're going to overlay on that a statistical system, calculations that are going to build a distribution around the performance that we have based on how we did, but then also based on our characteristics, or height, or age, or weight, and how other people with those characteristics did when they tried 90, when they tried 100, and so on. So that's underlying what we do, and that's supported by this psychological perspective that you can line these things up. You can have easy task, difficult task, middle task, and then you can also you can assume that if you jump this high, that you will be able to jump lower. There's a little very, very important caveat here, or a very important clarification here, is that the question in athletics is how high can you jump? So who can jump the highest? And that's what the Olympics is about. In education and in this item response theory systems, the question that we're answering is, what's the difficulty of the items of which I get half of them right? So when you say that the score is, my score is 520, what you're saying is that if you gave me an infinite number of questions of difficulty 520, I will get half of them right and half of them wrong. So that's underlying. That's the concept underlying these this scaling and the scores that we produce, and that you use for your analysis. So when somebody asks you who's doing better, there's a 10-point difference. A 10-point difference has an uncertainty around it, and that uncertainty needs to be taken into account for the purposes of making inferences about those results. And that's why when you look the user manuals for the databases that we produce, there's extensive information about how to calculate the errors, how to provide. We also provide computer software that you could use for the analysis. And that's another advantage of the advances in computing, is that nowadays when we started doing this, there was a lot of coding that had to be done. Now there's programs with interfaces that you can click and select your variables, and then the program will create the code and the syntax to do the analysis. So that's yet another advantage or gain of this of the increase or use of artificial intelligence. So, but it becomes more difficult to describe and then to establish. Imagine if I said to you, okay, based on that, what's the height that I would have a 50-50 chance of being able to jump? And then it becomes a much more. It's not just a number like how high can I jump, but where is the 50-50, my 50-50 level? So some of the functions of the so we do this so that then we can use these large-scale assessments for the purposes that for research. So why are governments interested in this? Back in the 90s, actually in the 80s, after the fall of the Berlin Wall, in the United States, the Cold War was over. There was no more Cold War. Now all this money that we're spending on protecting ourselves from Russia and so on, from the Soviet Union, now we want to spend it on developing technology. So the idea was to figure out who has the best students, and finance the development of skills and knowledge. And that's why from the 90s, there's all this development in large-scale assessments. The first assessments were financed pretty much, the international overhead was financed by the United States, because they wanted to benchmark themselves. They say, who has the best students in the world? So that's one function of these large-scale assessments. Another one is the analytical function, which is, that's why we have background questionnaires. So we have background questionnaires to then be able to relate contextual variables with student achievement. So what are the characteristics of the students that are doing better or worse in the assessment? But as you can imagine, there's in the session there was one session where they said, they could ask about this. We could ask about many things, but we have a limited amount of time in the assessment. So I think it's important to be able to pick and choose the variables that are most important to be asked and included in the assessment, to then be able to do these types of analysis that you're all working on and presenting here. There's an inventory function to see, you know, what is it that people know, what is it that they don't know, and then to be able to allocate funds to that. Some of you might have heard of the PISA shock in Germany when the first PISA results came out in 2001, where the Germans thought that the Germans were going to outdo the world in math, science, and reading literacy, and the results were relatively poor given given what Germany was at the time. Same thing in the U.S. I mean, when people ask about the results of the U.S., the question is how are they doing relative to how well they could do, given all the resources that the country has. So that's why it's an important function for countries. And again, I think this is an important function of the work that is done by people that use this data, is to figure out where, you know, what's happening in which groups. That's why we collect demographic information to be able to report by relevant subgroups within each one of the countries. And there's also a development function. So part of what has happened over the years is that countries that don't have national assessments have joined these large-scale assessments to be able to learn and train their staff on how to run these assessments. So that's been a great, it's been a function, an indirect function, but has also been a function. And now donor organizations like the World Bank, the World Bank they finance country participation in this international large-scale assessment so that the ministry staff will learn how to do them, and then they would go off and develop their own national assessments. So I'm gonna end with this slide because we started a little late, and I see I have 5 minutes, and I want to leave some time for questions. But some of the ideas that come later I brought to the front, so you're not missing. You might be missing the delivery, but I don't think you're missing on the ideas that I wanted to convey. So the why do we care about this? Because we want to assess preparedness for today and for tomorrow, and that's underlying this. We want to know, do we have the skills for today, but also for tomorrow? But we don't know what tomorrow is going to look like. And I think if you had asked people in 1994 that we could have the things that we have now, it would have been like a Julius Verne novel, you know, that where he talked about going out around the world in the submarine and all things that he imagined, but that, you know, we do know what tomorrow will look like. But do we know what tomorrow will look like and what skills and knowledge will be necessary? We have some idea, and knowing how students do in today's world helps us make informed guesses about how they will likely do tomorrow, to the extent that we know. This could lead to emphasis on skills and not so much on knowledge, but skills do not operate in a vacuum. So, and here I want to touch on the topic that you need to know things. You need to know things to be able to do things. So it's not all about doing, but about knowing. So I think I'm kind of like highlighting the importance of knowing facts and being able to have knowledge that then supports the things that you do. And that's why when you're making this test, you want to make the items innovative, and you want to make the students do nice and fancy things, but you also want to see whether they know how to add up things, how to do divisions, how to subtract, and how to identify a character in a novel. How to do they know the water cycle? You know, things like that is also important to know. So I'm going to stop here. Like I said, I have like a few more slides, but the ideas in those slides I've inserted throughout my talk. So you're not. I don't think you're missing. And even if I had gone through it, you might have been exposed to the content. And I think I thank you, and I think we have a few minutes for questions.
Thank you.
Yeah.
So now it's time for questions. If you have any questions. I have question number one.
Okay.
Just to give time to people to wake up and things like that. It's many of us are using that data set, and from time to time you say maybe they have been cheating. Now, how can you prevent that a specific country, or do you have any suspect, or is there any quality control? Because I mean, we trust your data. Okay,
No.
we believe in that data.
No,
so
so good. No. I know that. I mean, you shouldn't trust it blindly. So it's good that you trust it, but there's quality control back in countries. There have been instances where countries cheat, and sometimes they cheat because they know they're cheating, and sometimes they cheat because they don't know that that's cheating. So, for example, we had an instance where a country in teams we select classes at random. So if you go to school, there's 3 classrooms. You choose 1 or 3 at random, and we had one country where they always picked class A. So we got A, B, C. All those pick class A. They said because the students the classes do the same, but then when we inquire more, the students are assigned to classrooms by last name, alphabetical. So if you believe that when you sort names, that gives you a random sample of people, that is not true. So you have very few people that start with letter Z and Y and so on, and X. For example, many of the Chinese names begin with X, Z, Y. So if you always pick class A, you would miss many of people with Chinese last names. Am I right? That they would not be in class A, so you would miss them, right? So if you pick and then you would go through the other letters, so there isn't a random assignment of. So that was one instance. There was an instance where they selected. It came back with 5 students per school for some reason, and they were all very good. There are part of the questions. Some of the questions are scored, are open-ended, so people provide an answer, and then a teacher reads them, and then they score them. And there are techniques. You look at how countries do on each of the items relative to the other countries. You look at how they selected the students. You look at now that the test is delivered on computer, you can look at the timing that it took to answer the questions. You can look at how they navigated through the test. So there are ways of. Do we detect every kind of cheating? I don't know that we do, but we do a lot of quality control to ensure that, or to be confident enough that the response data supports. Is the response data was given by a representative sample of students in the country?
Okay.
Yeah.
Thank you. Anyone else? Yeah, please.
Thank you very much for your lecture. I have a short question. Do you explain us about the potential of these databases? And my opinion is that databases give us only data, not information. In order to modify the public policy on education, in order to modify the curriculum.
Mm-hmm.
And then my question is, if I become a policymaker and want to really improve my educational system, how can I to take this information to really try to implement it new ideas or implement a new methodological modification in my educational system?
So I talk about my professor back in 1993, and he used to say, we know how to measure quite well, but we don't know what to do with what we're measuring quite well. So it's a challenge. I mean, the answer is it's a challenge, and that's why the IEA and the OECD they make public the databases. There's transparency. We make public analysis tools. We conduct training for people like you and everybody here to use the data and gather evidence in support of decisions. And I want to emphasize that there's that this is part of the process of gathering evidence to support decisions to do or not do certain things. And the contribution of and it's hard for us to make recommendations that would be applicable to anywhere, So back when the first results came up in 95, Singapore came up ahead, and people were like, Singapore became like a educational tourism mecca. People were going to see what are the Singaporeans doing. And Singapore has a political system that is very different from what is here. So you want to try to implement here what they do in Singapore, you're not going to succeed. So part of the challenge is how to contextualize the results, to make recommendations, and then going back to what I said earlier today, like that the recommendations that will meet the right time to be implemented. It's not encouraging in the sense that I cannot say this is what you have to do, but it is encouraging in the sense that this is part of the process of gathering evidence and information to be ready for when a decision needs to be made. You have, and it has to be contextualized, and that's the importance of knowing the system, knowing what's possible, and trying to develop that.
Thank you.
Yeah.
More questions? Maybe people from the INE, it's a special friend. No, this is, yes, please.
Just a reflection. I want you to I want to know how you think about this reflection. All these organizations, IEA, with these evaluations, they try, and you started your communication saying we must predict what, because we are going to do 2031 evaluation. We have to start now, and so we have to be aware of what is going to happen. And so then you develop new things. How can we deal with new computers, with all these things. But my reflection is that artificial intelligence perhaps has come back to the basics, because to deal with artificial intelligence, you don't need to know a lot about computers. It's very easy, but what you need is to do what you have been evaluating from the beginning, this reading. Reading, or the main domains are reading, mathematics, and science. So what you need with artificial intelligence is just to read and to comprehend what the machine, what the artificial intelligence gives to you. So perhaps now, my reflection is that it's so important, the reading, for example,
Yeah. Reading and writing also, or talking, to be able to prompt, to create a prompt for the machine.
Yes.
I think it depends. It depends. I think you still have to know or be able to judge that what the machine is giving you is the right thing. I mean, that's one thing that's key. It's the and I give you an example. We were looking to increase the number of plausible values that are used for the analysis, and I was running it through the program, through the IDB analyzer, and it was taking a very long time. And what I did is I took the code, I put it into the ChatGPT and said, "Here's my problem. Here's the code. Can you fix it?" And it said, "You can do this. You can take a shortcut." So the program, a bit of history, back in the early days, when you had 5 plausible values, you would use the first one to estimate the sampling variance, and then use the 5 to estimate the measurement variance. As computers got faster, now we use the 5 to do the sampling variance, and the 5 for the measurement variance. So the code in the IDB analyzer still has the shortcut method in there. So I fed it to the ChatGPT, and very smartly he said, "There's a shortcut there. Use the shortcut." And I said, "Yeah, but the shortcut is outdated. It doesn't know that." what I was looking for was efficiencies in the code in the way that the data was processed. So I think you still need to have, that's what I'm saying, basic knowledge. Reading will become more important. Reading or being able to articulate what you want to the system has become much more important. But I think the other skills, you still need them. I went to the hotel to buy a bottle of water and pay cash. But cash is less used now. So there's still a lot of things that you need to, if somebody gives you, you have a budget and you're buying an airplane ticket and a train ticket, you need to be able to know if the sum of those is going to be within the budget that they gave. And it might be more difficult to put it through an artificial intelligence system to do that, unless it's a platform that says buy the airplane ticket and the train ticket together, and then you will need to do that summation. But so, I think but to your point, I think there's much more emphasis now in being able to read or listen to what the system is telling you, and being able to generate a prompt that will give you the right answer. So reading is become more and more essential to our daily lives.
Any more questions? So just a petition.
A petition, okay.
Will it be possible to delay 1 more year everything?
What do you mean?
Because we don't have time to complete all research. Every 3 years, new data coming.
You can hurry up.
I don't know.
You can hurry up, do it faster.
Okay.
Or you can use ChatGPT. ChatGPT lets you do a lot of things. So.
Yeah, they told me
I think it's, yeah.
They told me that in Pulse, they are trying to use ChatGPT to read the answer of the students.
Yeah. So one of the things that
they don't know that. It's interesting.
Yeah. So one of the things that we're doing is we're using large language models, and we feed it the answers to the questions, and then the system will score it. The challenge here is that we have answers in 60 different languages. So you wanna make sure that the system is able to, and amazingly it does. I mean, amazingly it does very well and does better than humans.
But it's open answered.
Yeah, open. You say, but very simple. It's one sentence. So it says, why there's a story, and it says what did Jose tell Maria, and then you read the text and you write it down, or how was Maria feeling about Carmen? How do you think Maria felt about Carmen when Carmen did something? And you write, and then it's a scoring guide. So you feed it the text, the scoring guide, and the responses, and it does better than humans. It was better than humans because the machine doesn't get hungry, doesn't get sleepy. So if you're scoring now 130 and you're thinking this guy keeps talking, lunch is waiting, right? So your scoring performance is going to be it's not going to be exactly the same throughout. The machine, it doesn't matter whether it's hot or cold outside, it will score the same. So the evidence is that the machine does better than humans.
And you need a lot of resources because you have to recruit all the evaluators.
Then there's that. Yeah, it's very time consuming. The doing the scoring by humans is very time consuming. Yes.
So thank you very much. Eugenio is going to be with us today and tonight. And so if you have questions in English or in Spanish about what is behind the data, he knows everything, right? You're like, excuse me, I had that curiosity. How is possible that that? So one-on-one, he will answer anything, okay? So let me give thanks very much for coming here. Any advice, Carmen or someone? Maria Jesus, any advice on the lunch is here?